Thank you. Thank you, Timo. Thank you, everybody, for being here. It's a great rule that you just said. My rule is, if I'm attending a talk, I go talk to the speaker. So you should all come to me to at least introduce yourself, because, again, like we are here to network and to meet other people. So I'm going to talk about cloud native AI, which is an important topic. It was introduced already. AI, who hasn't talked about it or heard about it. First of all, I want to thank all the organizers. It's my second year here, so maybe it's going to be like a tradition to come to Romania. And hello from my family. It's a big one. We got 5 kids, and we live in the Netherlands as well, indeed. I'm Italian, my wife is Greek, so this is in Greece actually, and this is like a hello from our big family. I also run the meetup there, the Cloud Native Community Days Amsterdam as well, so if you ever come to Amsterdam, do let me know. And you want to speak, you want to attend one of the meetups, we run them every month, so it's something that I've been doing for a while, and I really love it, and I have great respect for people that spend their time and effort, sometimes their money, in organizing this stuff. So we got only 30 minutes, so I'm going to rush through and talk about some personal story about where I come from. I'm 49. I know, surprising. I mean, you've never seen somebody looking so good talking about Kubernetes, right? So I'm 49. I was born in 1976. This was my first computer. Definitely not AI infused or AI capable, but it was a lot of fun, right? So and this was my second computer. Who can guess what this was? Nobody? Okay. It's an Amiga, by the way. And this was my third computer. My first Linux distribution, Slackware 0.9. Anybody ever installed a Slackware? Yes, we can talk. There was brave of me. And then it was my fourth computer, a Windows machine, Windows 3.11, by the way. And so just to say that I've seen a lot of things in my life. I'm not done by any stretch of imagination. I plan to live very long and see it all. But we've been through a lot of changes. And this is just accelerating. I didn't have one of these. I didn't even have a phone when I was growing up. Maybe it was for the better. But now we got this, like a 5,000 Commodore 64 in your pocket. It's kind of crazy. And then we have these. This is actually one of the Azure data centers in the Netherlands. You know what these are? Those in France? Anybody knows? Those are flowers. These are serre, where they grow flowers, because being the Netherlands, of course, we do few things right, including flowers. So this is a giant computer, right? So this is one single computing machine. And soon enough, the evolution of models and techniques and just human ingenuity and progress brought us where we are today, which is a place where this AI can do very crazy stuff, right? So every day I'm amazed by this super fast Abacus, which is GPT models, of course, but they are so fast that they are indistinguishable from magic, right? So don't remember who said that, every technology advanced enough, I think it was Asimov, is indistinguishable from magic. And that's where we are now. Like, this is magic. It's kind of, for all effect, if a person from even 100 years ago would be catapulted today with a time machine, he will not believe his eyes or his ears. Because we are in this world where things are going very fast, and if you don't want to be left behind, I always have this thing, like, if you stand still, you're going backwards, right? So if you don't get on board with technology, there's always if you don't control technology, technology will control you. So this is not the place where you want to be. You want to be on top of things. I'm trying my best, actually, every day to learn something more, and that's why we are here. We're going to talk about some ways to deploy these magic potions of models into your cluster. So Large language models are everywhere. If you heard about, so actually this is scary because we give an alien species our crown jewels, which was language. Right? We humans have one characteristic that separates them from the rest of the animal world, is that we can communicate ideas. And we took that and we just donated for free to some big machines that eventually might destroy us. But let's not be catastrophic. But these are the last 4, actually this stops in 2024. Yeah, so this is pretty accurate and updated. These are billions of parameters and the time, right? So this is just going up. And I think now we're actually going a bit down, as in we realize we don't need all these parameters. We can be smarter about it and be more efficient with what we do with models. So it's not, this, I don't think it's going to be like a asymptotic growth, but we might see a slight inflection of parameters. But it's true that more parameters makes for a better model. More data, more vectors that the model can see and can reason about, it will make for better responses. So this doesn't come without a cost. If you see the sticker here, I used to be part of the technical advisory group within the Cloud Native Computing Foundation for environmental sustainability. This is real. This is the most. This is the only topic we should really talk about. Like environmental sustainability is the most important thing we can do right now to tame and to control and to make sure that this big progress doesn't, first of all, doesn't kill the planet, and second of all, doesn't get concentrated in the hands of the few, but is actually spread to more people. This is the water consumption of running inference. I don't know if it's true, or I mean, it's pretty vague, of course. But every time you write a prompt of 100 words in ChatGPT, there's 3 bottles of water. So think about it. It's not only emissions. It's not only electricity. Water is also a scarcer source. Famously, somebody said the next world war will be fought over water. So that's think about it. Join the tag environmental sustainability. So it's a group within the CNCF that discusses these topics, how to make the software greener and the world safer, and also publishes something about AI and sustainability. But that's for another day. So we're here. We're making all apps intelligent, as in I wish we also would make people more intelligent, I guess. But for now, we focus on apps. So apps needs to be intelligent, or that's the trend we see. And it's not only, this is how it works, right? So that's the first thing you do. Like I'm using OpenAI. I'm using API somewhere. There is some load balancer behind api.openai.com. I don't even know where these models are running. I know that they are there for me to send my request, and they're going to give me a response. It works, but have you ever heard the European sovereignty or sovereign cloud? Not everybody is happy with this model. Not everybody is on board sending data across the ocean to some American company. And I work for one. I'm guilty as charged. But it's a different world today. We are working towards more sovereign clouds, right? So, okay, well, we at Microsoft, we offer you also your own playground where you can deploy your own models. Well, not your own models, the models that you have. You can train them, you can fine-tune them, you can add some data to it with a RAG, but it's something that runs at least in your garden, right? So something that it comes from abroad, it comes from somewhere else, but something you can understand. It runs in your Azure subscription. It's maybe safer than just some anonymous API endpoint somewhere. It's something you can control. You can put a gateway in front, you can put a firewall in front, you can control it. Okay, is there another way? Is there better ways? So then comes cloud native, right? So Cloud native, I've been talking about it for the last almost decade. It's this way of building applications that are more agile, right? So more sexy in a way. So based on microservices, and the classical definition is cloud native is very vague, by the way. By intentionally vague definition of cloud native is this application based on microservices, API first, probably containerized, most likely, and embracing this old DevOps. So it comes from DevOps and brings all the good stuff into the world of application. And one thing is, of course, automating everything. I'm going to skip through because I want to do the demo, and the demo is 45 minutes, so I better hurry up. So, and by the way, all this stuff we build, we got to build it with safety in mind, right? So safety first. All right, so where we are with Cloud Native and AI. So as I said, there is a thing called, within the Cloud Native Complete Foundation, which by the way is a daughter of the Linux Foundation, there are tags, technical advisory groups. Soon enough, 2 years ago, of course, ChatGPT, everybody was talking about AI. The interest of the CNCF group, of the people of CNCF, really, not the leadership per se, but also the people that work every day with Cloud Native, was to talk about this stuff. So this working group AI was formed. It was placed under the technical advisory group runtime, which are the people that take care of projects like Containerd and Fleckar Linux, by the way, which I think is in the other room. So all things related to running containers, so running WASM. Also, WebAssembly is part of the tag runtime. So AI, for some reason, not everybody was happy with the decision, was placed under the tag runtime. And they create white papers, guidance, maturity models, same things we do in the tag environmental sustainability, just for AI. The interest is huge. Famously, OpenAI, sponsored by Microsoft. I mean, it's clear. OpenAI is heavily funded by Microsoft. Runs these huge Kubernetes clusters to train the GPT model. So GPT-3, 3.5, 4. And we don't know much about it because this blog post was, I think, a couple of years ago. But they were running 7,500 nodes, which was quite impressive, being the limit of Kubernetes to be 5,000 nodes. I think still now. If you want to go beyond the 5,000 mark, you need to do something special. So see, Kubernetes Cloud Native enables you to run these models at scale and kind of feeds back into AI, into the AI world, what we learn about running distributed application in Kubernetes. All right. So this is also from the white paper. It's great. So there are many projects within the tag runtime, including Kubeflow, KSGPT, which I'm going to show you, QA with a K, which is a scheduler for machine learning jobs, Volcano, another scheduler, and so on. And of course, Kubeflow is the most important, the one that everybody thinks about when you think about cloud native AI. Everything, oh, it's Kubeflow. Well, I'm going to show you something else today, which is project. I'm going to drum roll. It's called Kaito, which I think I look it up. What does it mean in Japanese? I don't remember, but it's also some meaning in Japanese. But Kaito stands for the Kubernetes AI toolchain operator. So what it is a way to run models in your cluster. As we said, like we don't trust these big bad American providers. Fine, run your own Kubernetes cluster and run your own models in it. What can go wrong? Not much. So what can go right? Can go that you have now fully controlled access to your models. Right. So it's, in a nutshell, it's a way to run models. Models are big databases of vector embeddings, really, at scale in Kubernetes without too much trouble, which is not easy. I didn't know how to run a model in Kubernetes before Kaito. I know there was something involving Llama and a bunch of stuff that I didn't really understand, or I didn't need to. And then all of a sudden, 2 years ago, came Kaito, and then I started to deploy my models in Kubernetes. So these are mostly open source models, things you can download from Hugging Face, so nothing secret, nothing. Of course, like it's the whole debate, how open is a model? Is it open source, as you can inspect the training data, or it just the model is distributed over for free or at GitHub or Hugging Face? So the open is not the same in AI model space. Being open source doesn't mean the same as code, but that's another topic for another day. But these are mostly open source models you can download and use them in your cluster. So why it matters? Because then you can run your own OpenAI, right? So not only something that we also offer as a service, but running your own stuff in Kubernetes. So wherever you can run Kubernetes, you can run these models, which is also pretty impressive, right? So instead of running in virtual machines, you have to bring up the virtual machines and install a bunch of stuff. I'll show you how easy it is to deploy AI models in Kubernetes. So Kaito stands for Kubernetes AI Toolchain Operator, so which is a way to tell that is an operator, right? So it's something you run in your cluster, and then watches for some CRD to be created, and then does something with it. It's a tool chain, so it's both the operator, the CRD, but also the images we push on public registry and so on. So it is a way to do inference and deployment and serving those models at scale, and it all runs in Kubernetes. I'm gonna use AKS today because, well, it's not free for me. Actually, it's not even Microsoft subscription, it's my own subscription. So that's why I'm in a rush, because I want to switch off those clusters pretty soon, because otherwise I'm going to pay from my own pocket, which is, it's okay, but these GPU machines that actually I'm going to show you, if you run them 24/7 for a month, it's like $5,000. So I think it's something like $5, $10 an hour, depending on the size of the machine. So I'm on a clock here, right? So as soon as I finish, I'm just going to delete the workspace and go. So Kaito is an architecture. It's pretty much the same architecture of all operators out there, right? So there is a controller looking for the custom resources. And when the custom resource pops up or is updated, then does something. This something is prepare the node. So spin up a node with Carpenter. Carpenter is an open source project born in AWS and now being actually imported into Azure or GCP. So you can, Carpenter is a way to, is a better autoscaler because it is not fixed on the same node size. You can choose the node size based on your workload and make a smarter decision on what to do with your workload. So he leveraged Carpenter. He used a thing called GPU node provisioner, which in turn used Carpenter. And the most important thing is the workspace. So what is the workspace? Oh, and this is why it's so cool. You go from, like a bunch of operation to 1, 2, maybe 3. So this is the workspace, and it defines everything you need to know or you need to define about your model. How do you deploy? So, and it's all based on presets. So the Kaito maintainers defines presets. So you don't even need to look up which GPU is going to work with this. Which is it? How big is this model? Or can I? What are the parameters of VLLM, which is the serving tool that we use? What are the parameters to optimize the serving of the model, the inference, when I run this model? No, it's all part of the preset, being tested and known to work. And then you can, of course, fine-tune it. You can change it later, right? So it's not, you're not stuck to the presets. You can also use it to fine-tune, as in, like get your models to be better and more attuned to your data. So you have to prepare another image, give it to the workspace, and then it's going to use that. And so on. There are more things on the roadmap, including RAG, fine-tuning, and we heard about MCP at the keynote, the Flux operator MCP, so the model context protocol. I didn't get it run. I wanted to actually put it in the demo, but it was too much. Actually, there is no way to do it as of now, but I want to point you to the hype word of the day, which is MCP. Friends of mine, like Rohit, has this huge list of MCP servers. Azure has his own MCP server. Rohit made this kubectl MCP server. So my idea but maybe next year or next month, I could run the model and have the model talk to the Kubernetes cluster itself to see what's going on and to get information out and push it back and do operation on it. But yeah, so MCP is another thing. And now for the demo. So I think you can see it. Let's see, this one is better. So everything is on GitHub. Let me show you. No, I cannot show you. You don't see it. Let me mirror it. 1 second. Better now? Right. So everything is on my GitHub account under demos. I'm starting to collect all my demos into a single repository. So I don't have hundreds of repositories on GitHub. But it's here, right? So everything is here. So what is going on here? I have, of course, an AKS cluster. AKS is Azure Kubernetes Service, and it's the most convenient way to run Kubernetes in Azure, because I love it, and it works just fine. I did pre-create this stuff because it takes 4 or 5 minutes to provision a GPU. But you can see here, and I'll make it bigger, not just for you, but also because I don't see very well. But this is how it works. So I'm defining a size, and then this is the object, the workspace. I pre-pushed the image on my own ACR, so the model, I pull it from Microsoft Container Registry, and I push it. I could have just as well built my own Docker image with my model and push it, but in this case I'm just using one of these predefined model. It's actually Phi-4. It's one open source model from Microsoft. It's not the greatest model, to be honest. I mean, especially because we are spoiled. We use cloud and GPT-4o and all this amazing models. So it's not exactly it's not gonna make you wow, but it's a decent, honest model, and it works well. I'm using a config map as well to actually fine-tune VLLM, which is the inference serving server that we use in front of the model. So for example, because this size has 4 Tesla NVIDIA GPUs, so I'm using tensor parallel size 4, and I have to reduce the max model length, but I did it for you, so you don't need to go crazy about it, because I spent all night checking all these models if they were running. So you can see there's a workspace running, and it's running. So when I ran it, it created this node, which is this off one, you see? So this node is actually the GPU. You can tell from the labels on it that it has type standard. So the node comes up, and then the pod containing the model comes up, and it's ready to serve my models. the model, the phi 4. So what can you do with it? Of course, you have, I deployed, let's put it white. There is also part of the Kaito repository. There is a chain-lit UI. It's very nice. So I think I wrote some prompts over here. You can put some prompts, and it's pretty fast because it doesn't need to go anywhere. The UI is talking to the model within the same cluster. It can give you answer. It can give you, and it knows a lot. Even why did you change the name to Cloud Native Days Romania? Not only that, I also add to the demo a fancy little thing called K6. Who knows what K6 is? So I want to load test my model, right? So how do you do that? And then I want to do something smart. I use a model, of course, to write this. It's like 1,000 prompts. K6 is a load testing tool from Grafana. So it can just make queries, HTTP, you see HTTP post to my model, which is exposed via HTTPS, by the way. You don't see that often, especially in the demos you see about Kaito. They were just all plain HTTP, but I use Gateway API. It's all in the demo somewhere around here, how to do it. So this is actually running and is sending these 1,000 prompts 100 at a time to the model. And then, I use Grafana. So VLLM expose Prometheus metrics over, of course, like a Prometheus port. So actually, I was curious to see, okay, how does it perform? How many token throughput I can get out of this? I think I got to 900. I know that they told me, don't show things in black. So where do you do this? Profile. That's better. So also the dashboard is in the repo. It's there. So you can see that actually it's pretty nicely ramping up, and you can tell the latency, the average, and the P99 distribution of latency of this model. Oh, okay, can look at that. The time per output token latency also very important. So it's like how fast, but it's pretty fast. This stuff is 100 milliseconds on average, and it goes on and until it does this 1,000 tokens. So that's the demo I want to show. I show the graph. I chat with the model, and of course, like I want to, and I secure everything through, of course, Gateway API. So everything is secure. This is, you can see here, chat is HTTPS and so on. All right, so that's about it. So at this point, I'm actually, this thing didn't even run for a few hours, and I'm already, spending some serious money. I mean, 17 euros. I think in the beginning it was, when I started, it was 16 euros. So just for half an hour, I already spent a euro. It's a coffee in Italy, at least. So these are expensive stuff, and I'm not even using the biggest, right? So I'm using these ones that have not even the A100, which are not even the last ones, but they're pretty decent GPUs. So if you want to run DeepSeek, for example, you do need bigger machines, bigger GPU RAM. You mostly need enough GPU RAM to squeeze all the models in it. Now, this doesn't have a lot, so that's why we use like the FIFO mini instruct. I think it's only 3 billion parameters and so on. Anyway, so this is how it works. And you can see, so we show how to run models alternatively than just SAS and way to run LLMs in scale in Kubernetes. It's a CNCF project, by the way, so everybody's very welcome to join. It's a sandbox project, it's very early stage. So this was the way of cloud native AI, and I want to thank you, everybody. And maybe we have time for a question or not. Or not.